Hello, everyone. My name is Zanirud. Just a couple of slide deck to prove my candidacy for your research group. So let's get things started. I am currently pursuing my bachelor's in computer engineering here at Georgia Tech within the School of Electrical Computer Engineering. My concentrations are distributed systems software design, computer architecture, and cybersecurity. A few adjectives that can describe me is technophile, cloud enthusiast, and I kind of really like the interconnectivity between embedded systems and AI. I think that the biomems course that I've taken is very much relevant to type of work that you guys are looking for in terms of wearable electronics for future healthcare. The objective of this biomems course mainly consisted of a design of a microfluidic system for genetic analysis, starting with a purified sample of nucleated cells to be analyzed. The four functionalities in this microsystem consists of cell lysing, DNA extraction, PCR, and electrophoretic separation of amplified DNA. There was quite a few things that was involved in this project, and my target of work delegation was in regards to the supporting valves. So I'll kind of elaborate on that in just a second. And I've kind of labeled one, two, and three. I'd be more than happy to forward these correspondences over to you guys to take a look at the type of work that might be related. But continuing on, the overarching idea of what I worked on is this pneumatic valve structure, which consists of two states, on and off. And it comprises of an air chamber, a long silicon tube pipe, and the controller that supplies the air. The essential objective of this mechanism is that when the pressure in the chamber exceeds a certain threshold, it causes the PDMS membrane to act as a regulator to completely shut off the channel right here. When the air from the pressure decreases in the chamber, the membrane will slowly retract, allowing for unobstructed flow through the outlet. So the particles, essentially. Um, so there's, quantitative measures of how this structure was made. So it has a stress yield of 700 kPa and a few other quantitative measures. But we'll proceed on to other related factors. Another very prevalent aspect of what my experience consists of is in ubiquitous computing and human-computer interaction. It's essentially the third generation of computing taught by Professor Thad Starner here at Georgia Tech in the College of Computing. There's a variety of things that are essentially covered in this class. Fitts law, as the size of an object increases, the selection time goes down, and the distance between the user's starting point and the object decreases, so does the time to make that specific selection. And how these principles are very much relevant in making any accessory or uh, any any assistive technology for the impaired. A few other technologies that we've worked with is local location and localization technologies, specifically indoor localization. I'm sure you guys have tried to navigate inside of a building using Apple Maps, and you've come to find that it's not that very accurate. It's still very much of an unsolved problem. So basically, we learned to use Bluetooth Low Energy and our SSI received signal strength indication and how that behaves through a series of experiments, including interference object and a few others. And lastly, we are, in the realm of context-aware computing, where, as I mentioned, like localization can be referred to looking for activity recognition to get location or location to get activity recognition. And we've kind of encompassed the principles of what this course is trying to teach us in the ubiquitous computing project that I'm currently working on to assist the Able Alliance here at Georgia Tech. The Able Alliance is a organization for disabled or mobility impaired students here at Georgia Tech. And the essential vision of this goal is to increase the 10% of the world population that has access to assistive technology when they need it compared to the rest of the world. We're trying to increase those quantitative numbers, essentially. So moving on. You guys have also mentioned a few prototyping and hardware skills that might be very relevant. Here are a few things that I've worked with, various Raspberry Pi I should have mentioned here as well. But, the king of prototyping essentially is Arduino, various sensors and actuators we have used, various projects that I've incorporated this with, including the wheelchair crash detection project that I'm working in the ubiquitous computing course, as well as a alarm mechanism using capacitive sensors and PIR ultrasonic technology. I've also had the privilege of using multimeters and oscilloscopes within the digital design course, which is a pre-requirement to many electrical computer engineers here at Georgia Tech. Computer architecture was one of my most passionate courses that I've taken, consisting of pipelining technologies, memory systems, virtualization, and concurrency, which was the most recent addition to the 4 credit hour course. We'll move on. So, internship experience. I have previously worked at 2 internships and a few undergraduate research opportunities. My first one is at CommScope, and I'll kind of pull in the slide deck here. So, essentially, I worked in the device. I worked in the design verification team where we focused on thermal protocols of cable modems or gateways. And we would want to automate the analysis of um, these thermal characterization files that are an outcome of doing hardware testing. And there was a lot of anomalies and discrepancies that the file analyzer model, which I created, was supposed to. It's supposed to act as an internal tool to be able to reduce the workload of engineers in the hardware design team. Great. So let's pull that back. And then the second one is in regards to Garmin International. At Garmin International, I coded a, a custom metrics endpoint in an application that I made using Flask. It consisted of a metrics endpoint, a health endpoint, and a few other gauge and histograms and metrics, essentially, to be able to scale Kubernetes pods based on custom metrics. I configured the Prometheus server to be able to scrape these custom metrics from the application metrics endpoint URL where the metrics were exposed. And then I verified with the Prometheus server that it's actually scraping by making PromQL queries in the Prometheus dashboard. After that, I used this thing called Prometheus Adapter to expose the custom metrics to the custom metrics REST API in Kubernetes, such that the team can use it to scale off whatever desired metric that they have. Subsequently, I created a horizontal pod autoscaler configuration to be able to scale applications based on custom metrics from the desired metric that they have chosen, and a specified scaling policy. Last but not least, we used Grafana and Kubernetes dashboard to be able to catch any 404s, and I actually created that dashboard to be able to show very many visuals of any HTTP requests or any other file analyzer models that may have been pertinent to what the team was trying to diagnose. I have another slide deck for that just to showcase in a few more words. Pull that over. All right. So imagine this. Your work has reached production clusters, and you worked so hard on this application that you've created here. And Kubernetes is currently holding a lot of several applications, and you would want to scale this based off of custom metrics such as HTTP requests or queue requests, alongside a few other resource utilization models such as CPU or RAM. So we will be able to throw this application into a Docker container, and we'll use Kubernetes as our container orchestration model to be able to scale using custom metrics. All right, so pull this back. I have also worked at undergraduate research team for AI-based innovation in discovery, where essentially the overarching idea of what we're trying to achieve is to increase and optimize the stock portfolio by coding AI ML algorithms using NLP and deep Q learning. So the very first accomplishment that I've made was in regards to OpenAI Gym to wrap the current reinforcement learning algorithm to test and in a custom testing environment to increase the Sharp ratio of a given profile. So I kind of mentioned the OpenAI Gym interface here, and I'll kind of elaborate on that very briefly. Um, so OpenAI Gym is to develop and compare reinforcement learning algorithms by providing a standard API to communicate between learning algorithms and various environments, right? It consists of a specific given interface, which consists of init, step, reset, and render. These are the functions that I have coded up to be able to increase or maximize Sharp ratio. So the init initializes the actions and other main assignments for your RL algorithm. The step consists of a observation space, and it contains the input variables that we'd want to consider, like should we make the trade or should we not make the trade? And we need to do these based off of some considerable stop data points. The subsequent one is reset. We would want to bring the current state of the algorithm back to the initial state after a certain number of time series steps have occurred, and we would essentially like to make new observations. The last but not least is the render function, and it just displays the result of the environment to the screen. Um, Overall, we train our agent with two well-established stocks in QQQ and SPY. These are our standard benchmark. I know the overarching idea of this research is to understand the basic machine learning architecture, which includes data preparation, feature engineering, model selection, model training, model repository, model serving, and model explanation. These, I guess you can consider as the basic infinity stones, which kind of operate under the hood. We don't have to worry about them. We just ingest the data and you see some sort of prediction. Favorable or not, that's a separate question. All right, continuing on. Oh, one more last bullet point that I'd like to notice. Most recent work here in regards to NLP models. We examine the text from Twitter using the Twitter API to establish a sentiment based off of a certain tweet that has been posted by a celebrity or a well-renowned person that may gauge the prediction of stock movements. And we establish a sentiment, -1, 0, or 1, and we predict where that stock would be forecasted to go in the subsequent days yet to come. Okay, continuing on. I also participated in the Georgia Undergraduate Research Conference and published a page in regards to transmission dynamics of COVID-19 in Italy and France. So in terms of research, it's nothing new to me. Um, Basically, we use JavaScript to be able to grab an initial set of raw data from the World Health Organization, and we created visual tools that showcase the prediction of 190 days of COVID statistics. To put things into action, research is one thing and executive action is another thing. And after promoting and presenting our observations to the Georgia Undergraduate Research Conference in 2020, we actually made regional efforts to send over 250 CPAP machines to highly infected countries. So bringing research from the lab into the reality is definitely one of the biggest accomplishments in this research that I have been experienced in. All right, next. These are a couple of undergraduate and graduate coursework that I've already completed. Um, I know the first one I've mentioned in an earlier slide, which is biomedical applications of MEMS technology, advanced topics in malware, semiconductor process control, computer architecture, computer networking, data structures and algorithms, object-oriented programming. And last, I also mentioned this, which is ubiquitous and mobile computing, which includes the human-computer interaction topics. The UbiComp class, as I mentioned, was taught by Professor Dat Starner, who is a pioneer actually for wearable computing technologies, including Google Glass. So, in terms of what you guys are trying to accomplish, I think I'm understanding the most basic fundamentals of being able to intersect my qualifications with your needs in this specific research that you're hiring for. Um, I will also mention, I don't know how much of a factor this plays in. My GPA is a 3.9, so that should not be a concern for both parties. Continuing on. All right, so my future goals and outlook. Um, the LinkedIn description that I've listed here is I'm currently trying to gain maximum exposure to state-of-art tech and software from internships and my institute. And I think that in terms of philosophy, being able to put things in practical hands-on experience is very much applicable than conceptualization topics. So I think the biggest takeaway from the presentation slide deck is that I may not be the perfect candidate, but I have that mindset of willing to learn. So I'll be able to bring things from inception to execution for sure. The second bullet point is debugging is a programmer's greatest virtue. Writing code is one thing. Learning how to debug code is a much bigger thing. Knowing where errors occur and where things are prone to occur is one of the biggest things that I've picked up from working in various courses, working alongside teaching assistants. And I think that debugging is a definite skill, one of my greatest skills that I would like to take pride in. I'm still expanding my knowledge in this aspect, but I'm more than happy. Um, in regards to your group and how I am focused to expand my knowledge in terms of what you guys are writing, I've included this bullet point twice to emphasize the fact that I have I have a very specific passion for data centric groups like yourselves. And in terms of being able to apply these knowledge that I've learned from courses into direct research is something that I'm very much open and willing to focus on. In my graduate coursework, I'll be focusing on bioengineering and computer systems and software, CSS, essentially. As I mentioned, I've already taken a few courses in master's coursework, and I kind of have an idea to follow through into the PhD route after completing the BSMS program. Last but not least, I will say thank you. I hope this was of some value to both of us. Um, I'm more than happy to answer any questions, and I mentioned that I will be forwarding you my resume and the correspondences which I've mentioned in the slides previously. I'm looking forward to having a conversation. Thank you so much.